Thanks for watching.
In this video, you'll learn about a common reaction type called a single replacement reaction.
So far, we've seen two other reaction types: synthesis, where two elements combine to form one compound in the products, and the opposite, decomposition, where one compound splits apart into its two composing elements. In this video, we're going to look at a third type of reaction called a single replacement. With single replacement reactions, you'll see a free element replace another element that is in a compound. The general formula looks like A plus BX turns into AX plus B. You might already be able to tell that the A and the B, highlighted in blue and red, tend to trade places with each other as they form the products. Here, the free element is being represented in blue by the letter A. It's called free because it's by itself, not bonded to anything else, and it's going to replace the position of the element in the compound represented with the letter B in red. You have to be a little bit careful depending on the types of elements that these atoms are. If the free element is a metal, it's only going to replace the metal that's in the compound. So here, lithium is my free element, and it happens to be a metal. So it's only going to replace potassium, since potassium is also a metal. And we'll see the same pattern if the free element is a nonmetal. It's only going to replace the nonmetal element in the compound. Fluorine, my free element, is a nonmetal, so now it's going to replace the chlorine, since chlorine is also a nonmetal. In our dancing analogy, we'll have one person dancing by themselves and another set of people dancing as a couple. The person by themselves will kick out the person in the red dress. Now the pink shirt is dancing in the couple, and the person in the red dress is dancing alone. And lastly, some real examples. Here you can see the magnesium kicks out the hydrogen, or in this reaction, the chlorine replaces the bromine. We do have one extra problem with single replacement reactions, and that is predicting if it will actually happen. Here, just because I mix Mg with HCl doesn't mean these products will actually occur in real life. Will the magnesium and the hydrogen actually trade places? To tell this, the guideline we use says that a free metal or nonmetal will only replace the metal or nonmetal in the compound if it is more reactive. And the way you tell if it is more reactive is simply by checking a reference list called an activity series or reactivity series that tells you which metals or nonmetals at the top are most reactive and which at the bottom are least reactive. So here, with lithium reacting with potassium chloride, simply find your two metals, Li and K. Lithium is more reactive than potassium. It's higher on the list, so they will replace each other. If, however, we mixed aluminum with potassium chloride, aluminum is less reactive than potassium, so that it will not replace and you won't get a reaction at all. Now let's apply all these skills and try to predict some products of single replacement reactions. In the first example, calcium is the free metal and it's reacting with aluminum fluoride. Since it's a metal, it's only going to potentially trade places with the Al because it's also a metal. First thing I need to do is find those two metals and see if they'll actually react. In this case, calcium is higher on the list, so it will replace the aluminum. So you can imagine the calcium kind of coming over, kicking out the Al, and now calcium gets to be the one that's bonded to the fluorine. At the same time, the aluminum gets kicked out to take the place of the calcium and ends up simply by itself as the new free element. After you've made your replacement, it's important to add in any subscripts to properly write the formulas for our products. Remember, just because there's a 3 here with fluorine, don't carry over that little 3 here. It doesn't work that way. To write this formula properly, we have to check the charges on the two elements that are now combined. Calcium has a +2, fluorine with a -1 means that the formula for Ca bonded to F is CaF2. Aluminum by itself does not need any subscripts, so our final products are CaF2 and Al. Let's try this one more time with zinc and barium chloride. Zinc is a metal, so it could potentially trade places with barium, since barium is also a metal. First, check to see if that trade will actually happen. Here's zinc, and here's barium all the way up here. In this case, zinc is less reactive than the barium, which means they will not trade places, which is kind of good news because you don't have to write those products because they wouldn't happen in real life. You would simply write the words no reaction to indicate that the switch does not take place. That concludes this video on single replacement reactions. Here's a brief summary.